Okay, I'm going to do one more example, slightly more complicated, because I'm going to have a few more variables in there. I'm going to use this equation that you might have seen in science. It's an equation for calculating the kinetic energy of a body in motion, anything. Could be a particle, tiny, could be a car. So we're calculating the kinetic energy. K is the kinetic energy in joules, which is the unit of energy. M is the mass of whatever it is we're talking about in kilograms. And V is the velocity. Velocity, you'll remember, is speed. I'm going to rearrange this formula. I'm going to make V the subject. So at the moment, K is the subject. I'm going to make V the subject. Go through exactly the same process. Just keeping everything balanced. You'll notice this time there's a squared in there, so that probably means we're going to have to take a square root at some point. The first thing I'm going to do, half mv squared, remember we're going to go through our BIDMAS, order of operations, PEMDAS, however you prefer, BODMAS, so a few different variations, all mean the same thing. I'm going to deal with the division, the half. It doesn't matter if you think of it as a division or as a multiplication. Multiplying by a half is the same as dividing by 2. Before I look at the other letters and the v squared in particular. So, first thing I want to do is get rid of the half. How do you get rid of a half? Multiply by 2. Multiply both sides by 2. I'm going to get 2k on the left is equal to mv squared on the right. And I want to get v on its own because I'm trying to make v the subject. So I need to get rid of that m as well. And obviously that m, we don't write it in usually. That m is being multiplied, so how to get rid of it is to divide. Divide both sides by m. This is no different to if it was a number. Just going to leave it in the bottom of a fraction in the denominator. 2k over m is equal to v squared. And this is the step now where we're going to deal with the square. Obviously we did the division and the multiplication before we look at the index square in this case. So let's get rid of the squared. And how do you get rid of a square? Well, we all know now. It's to take the square root both sides. Square root of v squared is obviously v. And this is really important when you're doing an operation like a square root or a multiplication or a division, that it's got to apply to the whole of the left-hand side. I can't just apply it to the top. I can't write root 2k over m, because then this section has been unchanged. That's incorrect. It's got to be the square root of everything, otherwise it doesn't make sense. So it's the square root of 2k over m. And the square root acts like a bracket. You can put brackets in as well if you want. They're a little bit superfluous, really. A little bit unnecessary. But there's the formula rearranged to make v the subject.